Hello, my fellow peers or some random viewers. My name is Tony, and I will be your guide in this video. And today, we'll be learning about balancing equations! Ah. Okay, it has some math in it, but...
Oh man,
this
sucks.
Okay, calm yourselves, guys. This is actually very easy. Basically, in order to balance a chemical equation, you have to get both sides to equal the same amount of chemicals. For example, this chemical equation is balanced because it has the same amount of oxygen and hydrogen on both sides. This simple yet elaborate process is called nope, that's not it. Nope. Stigmata? Okay, hold on. Okay, Stoichitry. There we go. Now, I bet some of you are thinking to yourselves,
why do we need equations? We're not gonna need it. We're not gonna use this in life. This isn't gonna help us get a job. It probably may help us in college, but it's not gonna help us get a job.
well, my friends, allow me to fancy you with an answer. Okay, so there's this scientist guy named Anthony Lavoisier who discovered something strange about the atom. See, when they discovered the atom, he found out that the atom cannot be destroyed or broken down any further since it's the smallest type of matter in the universe. They also can't be created by anything, so it's not possible to have an atom baby anytime soon. This is also known as the law of conservation of matter, which states that matter can neither be created nor destroyed. Like, seriously. It's like the cockroach and the nuclear bomb. Unless that little sucker gets squashed on impact or burnt by the fire. It just won't die at all. So, to recap, no atom is created nor destroyed in an equation. Well, now that you know why we balance equations, let's try and learn how to do it ourselves, okay? Okay, so here's an example problem I just so happened to randomly find on the internet. Yes, the internet has everything. Now, the first thing you want to do is make a line through the equation so that you can distinguish the two sides of the equation. So just put it through the arrow here. Next thing you want to do is to write down the amount of each chemical you already have, kind of like an inventory. You should probably start trying to balance out either of these two chemicals since it seems to be the biggest problem here. In this case, we'll be working with carbon first, or C. Since there's 5 carbon atoms on the left side, we have to put a 5 in front of the other carbon so that they both even out. Since the carbon on the right has oxygen tagging along, you have to increase the oxygen as well. So 2 times 5 equals 10, so 10 oxygens. We also have hydrogen, or H, in the equation, so we have to balance them too. So put a 6 in front of the H on the right, since there's 12 hydrogens on the left. Again, the oxygen is along for the right as well, so increase the oxygen. Now we got the carbon and hydrogens balanced, but hold on a minute, we still have to balance oxygen. So since 2 times 8 equals 16, we have to put an 8 in front of the oxygen on the left so that it balances. Now after checking everything, you can see that the entire equation is now balanced. Here's another problem. Seems a bit tricky, but who cares about the easy stuff? Thought so. Okay, so same as last time. We're going to put the line through the equation so that we can tell which side has what. Next step is to make the inventory. It seems a bit trippy since the phosphorus and the oxygen are together, but the oxygen and the hydrogen are not. So just think of the PO4 as one atom, while the OH are separate. The easiest one that we can solve now is the calcium, or Ca in this equation. There are 3 calciums on the right, so we should put a 3 on the left to balance things out. Again, that 3 also increases whatever is joined with the calcium, in which case the oxygen and the hydrogen. Now we want to even out the PO4. Seems simple enough. Since the right has 2 of them, we should add a 2 on the left. This will also double the hydrogen with it as well. Okay, that's a lot of hydrogen and oxygen on the left. but there's barely anything on the right. We can even them out by putting a 6 in front of the H2O. Now the equation is officially balanced. See, that wasn't too harsh on you guys, right? Wow. So much support, guys. I mean, seriously? Well, that wraps up my lesson / project presentation / video comic whatevers. No questions? Yeah, that's what I thought. Until then, my fellow scientists. And remember, chemistry is awesome.